In this tutorial, these 4 objects plus some 3D text will be assembled into a new shape. A virtual digital probe will scan the top surface of the objects to create a new mesh. First, we'll clean out this workspace. And now we'll go to the File, Open As, menu item. This acts as a recent file list, and I can read in the last file of the type read for any one of the different file formats. I'll first go down to the wavefront object format and read in object mound.obj, which is the base object in what we're going to create. Okay, it's just a flat object, it's got a hollow bottom, it's just a top shell. Now we'll go into the Adjust Object group of controls. This gives us the size of the object, and we can see that it measures 1.2 and just about 2 units, so it's sort of round. The unit could be anything you want: a mile, a foot, an inch, a centimeter, and we can assume it's a centimeter for this operation. Now I'm going to take and scale this unit up by 10 so we can measure 12 units for the diameter. So I'll enter 10 here, copy this to the other ones, press the scale button, and we're now scaled up. When I assemble a lot of objects together, I like to keep them centered around the z-axis, starting off with the lowest elevation at 0, which is what we have here. So this is good. We'll exit out of here. Now I'll go down and I'll choose another workspace, and for the second object we'll go to the VRML file format, and we'll load in an object called hand. Okay, here we have a hand, and it's all closed in. We'll go up to the Adjust Object, and we can see that again we're centered around the axis, and this hand is 1 unit wide on the x-axis. So let's scale this one up by 5. Scale, and now we're up larger. We'll exit out of here. Now I'm going to copy this mesh to AccuTrans' Clipboard. So we'll do Copy Layers to Clipboard, go back to our original workspace, and this time I'll do Clipboard, Paste, and Move Layers from Clipboard. And there's our hand, and it's in green as it's the selected layer. And we can see it's down at the bottom. So I'm already selected on Move in the Adjust group of controls, so we'll move the hand up, which is moving on the Z-axis, and we'll get it up near the top. Okay, and then we can turn, and now I want to rotate the hand, and if I look down here I can see that this is on the Z-axis going in and out, and I'm on local coordinates, so I will take and go to the Rotate, and then I want to rotate around the x-axis, so that's the wrong direction. We'll move this way, and we'll tilt the hand back something like that. It's that far down. Oh, why don't we just raise it up a bit more? And we can, there we go. So we'll say that's okay, so we've got the hand in position now. So let's add some 3D text to this object. So I'll pick another workspace here, and I'll click on the text tool. I've already have a script type font selected, so let's put in some text. Okay, so now this text is set to be 1 unit high and whatever length it needs to go the other way, and it's going to be extruded to a depth of 0.1. And everything's going to be on 1 layer. It says we're going to join face and extrude the true type text. So let's click OK. Here's our text, and so we'll copy this text to the clipboard. We'll go back to our original workspace, and we will do a clipboard, paste and move layers. All we can see is the dot for its pivot point, but if we rotate, there's our text down there. Okay, it's right down at the 0 point for the axis system. So let's take and we'll first bring the text up. Okay, we can see it. Now here's the y-axis, positive going that way, negative y going this way. So I'll move on the y-axis, and there we come out. Now I'll move along the x-axis, go over here to scale. Let's size this object up on all the axes to get us to something we want. How's that? Okay, we'll rotate around. We're quite a ways above the object, so let's go back to move. We will come down somewhat. We're sinking in. Wait a minute. Let's go to the top view. We'll move a little bit further down there. A little bit over on the X. Okay. Come back up again. Okay. We'll call that good. Okay. So now what we want to do is we will have this object so it'll extrude down, and then we want to put another round shape around it. We could use whatever shape we want, but I'm going to go for round this time. So we'll pick a workspace, and this time I will go to the DXF file format, and I have an object disk all ready to go. Okay, here's our disk. We'll go to the adjust object, and I can see that it's in the XY plane, and already it's 0, and it's just on the but it's not quite centered around the axis. So first off, I'm going to scale it up. Should go down here, 13, copy that, scale it. Okay, it's now got a diameter of 13. Numbers are a little crazy up there, but and then we'll just do a center on the X, Y, and Z 0, and now it corrected itself. And so we'll go OK, and I'll do now again, copy layers to clipboard, go back to our original work area, and we'll do a clipboard, paste and move layers. Okay, so now we can see that, okay, we're right at the bottom of our original object, and that diameter's not quite large enough, doesn't look too good, so let's scale it up a bit. Okay, we'll call that good. And but now we come down. I want to have a little bit more of a gap between the mound and the disk, so I'll go back to move, and we'll just take and move down on the Z axis, and we'll go down to minus 0.15 units down, and we'll say OK. Now this is going to go into the digital terrain model, and digital terrains are always rectangular, and so even though we have this shape, the routine is going to put a rectangle around this, and it's going to touch some of the edges of the circle, which means that we can sometimes lose some of the faces on the side. So I'm going to put a rectangle of the size I want to force the module to give me that size. So I'll go back to another work area, and this time I'll use the Lightwave file format and bring in a plane, and this one has a texture map on. Doesn't matter because we won't be using it, so it can just sit there and display. So let's check this object, and now we can see that this one is in the XZ plane, and we need it in the XY plane. So we'll do a 90-degree rotation on the axis, and it's there, but OpenGL doesn't show it. If I switched display modes and went to say flat shading with edges, there you can see the edge. That's just the way OpenGL works. So we have the object up. It's measuring 2. We've already got a circle that's someplace over 13 units, so let's scale this one up by 8.5. And okay, so it's got it's 17 units on the side, and we'll say OK. Copy this to the clipboard again, go back to our original work area, and then do a clipboard paste and move layers, and there's our object with the circle down below. So now we want this one below the other one, and so I'm going to move, and this time I had moved the other one down 0.15 units, so I'll have to move this one a little bit further, and it doesn't really matter where we go. We'll go down that far, and then I'll click OK. So there's our object made up. Now, since as you're doing these things, in case of problems, you should frequently save as you go along, which I'm not doing. So, but just in case something happens later, I'm going to copy all these layers to the clipboard and select another work area and paste them in. Okay, so this is what we have here. Now we're going to operate the virtual digital probe. So we'll select the Convert Mesh to Landscape. Okay, now here's the overall size of the object, and now we have the probe does scanning at equal intervals on both the X and the Y axis. The smaller the number you have, the more vertices you're going to create. So I'm going to go with 0.3 units, hit calculate, and it says that there's going to be over 320,000 vertices, which is going to give us 640,000 triangles. Now, you have several options of what you want to do here. You can save out to an XYZ point cloud file. You could convert to a landscape, and then you can make adjustments in the landscape and then convert the landscape into a 3D mesh, or we could click here and go straight in to doing the 3D mesh and even convert it so that it's a watertight mesh for 3D printing. But we'll do the landscape route, and I'll click OK. Takes a little while to go, and here's our landscape. This is only a terrain. A digital terrain is only a collection of heights, and the X and Y distances and the actual mesh is calculated on the fly. Okay, so what I'm going, before I continue on, I'm going to save this as a contour map to a BMP file, which I'll use later on. And so I've got the file. We'll just leave it to that name, and I'll say save, and we will accept those settings, and now we have this picture saved. So now we want to convert this to a 3D mesh. So I could either go here to the DEM convert to 3D less water menu command, or press this button over here, which, before I do that, we'll come over here. Okay, now you know here you see east, north, and height. As I move the cursor over the object, you can see the different heights happening, and you can see that our lowest height is minus 0.32, where I had moved the square to, and the circle is at a minus 0.15. So now that we have to remember this number, minus 0.15. Now we go to convert the terrain to a 3D mesh. I click on this, and so now I can select different intervals if I didn't want to save everything out, and I'm going to get, if I did the whole thing without any trimming, there would be 640,000 triangles. What I'm going to do is click here on drop faces if elevation is at or below this amount. Now remember the minus 0.15. Well, I'm going to put in 0.17, so it will drop any faces that are at minus 0.7 or lower. And I'll click OK, and it's busy calculating for the mesh. And when as the 3D mesh is being created, UV coordinates are also created based on the rectangular shape of the original terrain, and this is so that you've got UV coordinates to work with after. Now, we don't want to see the default texture displayed on here, so we'll go and we'll just turn off texture display. Okay, so now you could take and save this file out to a DXF file or an STL file, and then send it into the software to calculate a toolpath to have this object cut out with CNC machinery. Okay, and we can see that it's all hollow underneath and so forth. Now, if I do a watertight check on this, it's going to say I've got a hole. Okay, so I'll say yes, and turn off that layer, and there's our hole around the outside because there is no bottom for this. Now, once we've saved it for CNC machining, if we also wanted to have it 3D printed, we could go into that module for the extrusion. Here's the size of our object, and I'll take and put a base on it. We'll say a 0.5 unit base. Say extrude. Oop, I left it on normal. I want a flat bottom on this, so we'll have to redo it as soon as it's done calculating. You can see it's got a hole and everything else down below, so I'll just click flat bottom here and do a redo, and now it's nice flat bottom, so forth, and say OK. Here's our object. We could save that out to an STL file and send it off to a printer, a 3D printer, and have this object printed. Now, remember the texture that I saved earlier? Well, I'll click on here, bring this up, select layers, do a browse, and here's the texture I saved earlier. Click open. Okay, I've got the texture loaded, and now I'll click on display, and there's our texture displayed that we'd saved before on the object. Now, if I save this out to an appropriate file format with the texture map, I could get this printed in a color 3D printer, and this is how it would look. So that's it for this tutorial. Goodbye.